The Finley Holiday slide cassette program that you are about to see and hear is the first of its kind ever made available to the public. And it is a new high in audio-visual entertainment for people of all ages. It's very simple to use. Please follow these instructions. First, place your 40 slides in the projector and move to slide 1. Then, each time that you hear the tone, advance the slide. It's as simple as that. So now, sit back and let's enjoy the show.
Incredible, mysterious, inspiring. Which of man's words can describe the limitless universe in which we in our world abide? Hidden by the barriers of space and time, it has existed forever beyond the reach of man, unknown, unexplored. But now, at long last, those cosmic barriers have begun to lift, and man has had his first glimpse of those once secret domains. And what he has seen has left him stunned, reeling from the sights of what he has beheld. And the first faint comprehension of a universe so bizarre and bewildering as to challenge not only his very notions of matter and energy, but also his rationality. The universe has always been man's most complex enigma. Most of us, as a youngster or adult, have spent many hours gazing into that vast void filled with stars, trying our best to comprehend just what we are seeing and feeling so very small and insignificant. But now that we are just beginning to understand some of these mysteries, how can we account from a scientific point of view for the creation of this universe? Well, a great many of our finest astronomers believe that the universe began with a great bang, about 10 to 20 billion years ago, when a primordial mass exploded in a titanic holocaust. This fireball gradually cooled as it expanded outward, and giant clouds of swirling gas formed into celestial bodies. Entire galaxies took shape as they were propelled outward by the initial cataclysm. This world of the Big Bang may expand forever, or it may gradually slow and eventually collapse inward upon itself. But now let us explore some of these mind-boggling domains of our universe and see if we can give you a basic understanding of what our knowledge is today. In the enormous depths of space, there swirl vast clouds of cosmic dust and matter. These are known as nebulae. They are the birthplace of stars. Our own sun formed in just such a nebula. Here we see the overwhelming beauty of the giant Orion Nebula. Its temperature of 20,000 degrees is due to ultraviolet radiation from a group of 4 massive hot stars called trapezium. The Orion Nebula is one of the youngest objects in the sky, as it is believed that it began to shine only 25,000 years ago. Galaxies have sometimes been called island universes. In reality, they're enormous, spinning masses of billions of stars that also contain star clusters, nebulae, and vast amounts of cosmic matter. Even the smallest is much larger than any nebula. In fact, our own galaxy, the Milky Way, is over 100,000 light years across. By the way, a light year is a term used by astronomers to measure the vast distances in space. A light year is the distance that light travels in 1 year. And remember that light travels at the incredulous speed of 186,000 miles per second. Galaxies are classified into several distinct types. This is a spiral galaxy, so named because of the definite spiral arms extending outward from the central core. The greatest concentration of stars and matter is always found toward the galaxy's center. All galaxies, because of their spin, are normally quite flat. This excellent photo gives us a view of a galaxy from an edge-on view, showing us this flatness and also the congested core, filled with vast numbers of stars. Each galaxy contains billions of stars with some having more than 1,000 billion. Now imagine, if you can, that our visible universe contains at least 100 billion galaxies. Incredible. Star clusters are usually groups of stars recently formed from nebulae that will eventually drift apart and spread outward into the void of space. There are two major types of star clusters. Globular, which we see here, is a tightly packed sphere which often contains hundreds of thousands of glittering stars. This one is the Hercules globular cluster. The other type is known as the open cluster, which may contain only a few hundred stars. As our technology has advanced and our means of observation has become more powerful, the known universe has greatly expanded. But for every question that has been answered, many more unanswered ones have arisen. A good example of this is the incredible quasar, one of the most baffling objects in the universe. First discovered in 1960, quasars have remained until just now a complete mystery, and there are still many questions about them that are unanswered. This is known. They are by far the most distant objects in our universe. The most distant of them is an unbelievable 10 billion light years away. They are comparatively small, but yet emit such enormous amounts of energy that it taxes our comprehension to accept it. In fact, some quasars produce more energy than 100 large galaxies, totaling as many as 10,000 billion stars. Since the first quasar was discovered, seen here in this photo, 350 additional ones have been detected. Some astronomers believe that they are the core of a galaxy about to be born. We call our universe incredible, but recently a new astronomical theory has evolved that is so fantastic that it makes even the most startling celestial objects in space seem commonplace. This is the theory of the black holes. Here we see, in an artist's simulation, such a black hole swallowing up enormous amounts of cosmic matter from a nearby star. A black hole has never been seen, and very likely never will be. In reality, it is a celestial body, perhaps a collapsed star only a few miles in diameter, that has such enormous gravitational pull that even light cannot escape from it. Its power is so great that it can devour almost anything in space. The hole is in the center of an intensely hot spiraling ring of gas and is the scene of intense X-ray radiation. Earth-orbiting telescopes detected this radiation, leading to the first theoretical detection of a black hole. There is as yet no accepted theory for their possible creation. However, some advanced theories pale even the wildest science fiction. One such theorizes that matter drawn into a black hole emerges in a different universe, and that quasars are the opposite side of the coin, so to speak, being the site of ejection of this matter and energy into our own universe from another. Whatever they turn out to be, they are without doubt the most extraordinary phenomena so far observed in our incredible universe. When a star becomes nova, it literally explodes in a titanic release of energy. The Crab Nebula was once such a star. In the year 1054, that star destroyed itself in the violence of a supernova explosion. This great eruption was witnessed by Chinese astronomers and probably by American Indians in the southwest United States. It shone brightly for several months, so bright in fact that it was clearly visible by day. 900 years after it exploded, the remains of that star are still expanding outward, and it is still shining. The central star in this nebula is a pulsar. Pulsars are thought to be highly condensed collapsed stars, about 10 miles in diameter, that once erupted into supernovas, creating a colossal magnetic field wrapped with intensely high-powered energy. The pulsar, in effect, is the power generator for lighting the nebula. Neutron stars are similar to pulsars, possessing great gravity. The Veil Nebula is also the remains of a supernova. The Lacey effect is created by interstellar gas clouds. The name of this nebula is Dumbbell for obvious reasons. The Dumbbell is the most prominent planetary nebula in the sky. Planetary nebulae are among the most dramatic and beautiful of celestial bodies. These oddities were long ago called planetary because their outlines appear disk-like and seem to resemble the disks of planets. Actually, they are large, diffuse spherical clouds of gas that have been puffed out by hot, dying stars and are set to fluorescing by those stars. Another planetary nebula is the Ring Nebula. It is invisible to the naked eye, but through a telescope, it looks like a ghostly smoke ring. The ring is a sphere of gas, 1 light year across and 5,000 years distant. At its center is one of the hottest known stars. Its temperature of 100,000 degrees makes the gas fluoresce colorfully. The nebula was created when the hot star puffed off its outer layers. An awe-inspiring sight is the beautiful Trifid Nebula in Sagittarius. Here is the birthplace of stars, where hundreds of new suns will ignite during the next few million years. The Trifid is about the same size as the Orion Nebula, although at 3,000 light years, it is twice as far away. It is so named because of the 3 dark rifts which meet at the center. The energy supplied by the hot stars within the nebula cause the gases to fluoresce with brilliant colors. The Sombrero Galaxy contains more than 100 billion stars and is some 30 million light years from Earth. Hundreds of globular clusters form a halo about this massive galaxy, giving its outline a soft blur. The beauty of a graceful spiral nebula can be equaled by few things. Its massive spiral arms contain mostly blue supergiant stars, which illuminate the clouds of gas within the galaxy. This is an open star cluster, M-46, in the constellation of Puppis. It contains a planetary nebula which can be clearly seen here. Within most nebulae are extremely dense portions of condensed gas and dust. They are completely opaque. It is believed that these dense clouds ultimately will give birth to new stars, and that the matter within them is in the state of collapsing to form these stars. These dense dark areas are called globules. This is the Rosetta Nebula, a gigantic cloud 55 light years across and 2,600 light years distant. Recent calculations indicate 11,000 stars, each with the mass of our sun, could be formed from this nebula. 60 billion stars comprise the Whirlpool Galaxy, a smaller version of our own galaxy. This 40,000 light-year wide spiral is 14 million light years distant. The companion galaxy is an extension of the spiral arm. Many spirals have similar, smaller satellite galaxies. One of the most familiar objects in our heavens is the Horsehead Nebula in Orion. This gigantic cloud of gas and dust has assumed the shape of a horse's head. It is silhouetted against a nebular background. The beautiful Lagoon Nebula is a giant cloud of gas and dust in the constellation of Sagittarius. At this gas cloud center, new stars are being formed. Although we see it today as a striking red, our future descendants will see it illuminated by new hot blue giant stars. The bright star in this photo is known as Alpha Aurigae. Of interest here is the blue veil. This is known as nebulosity, and it is due to the presence of vast clouds of gas that are caused to glow by this giant blue star. This is another fine example of an edge-on galaxy. The dark band through its center is caused by obscuring dust clouds located in the galaxy's central plane. Innumerable stars of the Milky Way seen in the constellation of Sagittarius. Another example of a planetary nebula is this ringed one. Our own sun is expected to have such a planetary nebula shell around it in about 6 billion years, after it has passed through the dying red giant stage. The double star cluster in the constellation of Perseus, known as H and Chi Persei. It is believed to have formed from a gigantic cloud of dust and gas less than 10 million years ago. Each swarm of stars is about 100 light years wide. In a few million years, these two clusters will become fainter and more diffuse as the bright stars burn out and the remainder stray away into deep space. In the constellation of Ursa Major are two interesting galaxies, M-81 and M-82. Notice the fine filamentary wisps at the edge of each galaxy. There is evidence that M-82 is exploding. Of all the galaxies in space, no other is so important to us than our own Milky Way. Yet the insignificance of our own Earth in the immensity of the universe is now becoming very clear. We reside on a small planet whirling about a minor sun, which is part of an average galaxy. Yet this inconsiderable galaxy contains over 150 billion stars and thousands of nebulae, gas clouds, and star clusters. No one knows when it was created. The solar system is located in a spiral arm of our galaxy, and at present is in the Gould's Belt, a group of newborn stars only about 40 million years old. We are traveling around the galaxy at about 200 miles per second. Within the solar system lies our sun, known as Sol, and spinning around it are 9 planets. The largest of these is Jupiter, a bizarre colossus that dwarfs every standard of comparison familiar to Earthlings. 24 billion miles of surface, 88,700 miles in diameter, 1,000 times the volume of the Earth. The king of the planets would fill 1/3 the distance that separates the Earth from the moon. Clouds of enormous depth completely shroud its surface. Unbelievably violent storms with lightning bolts that would vaporize an entire city the size of New York may sweep its surface. The Great Red Spot may be such a storm. It is 3 times the diameter of Earth and has existed for hundreds of years with no end in sight. The planet's atmosphere is composed of methane, hydrogen, helium, ammonia, and some water. Jupiter is indeed an alien planet compared to our Earth. Note the moon Io silhouetted against Jupiter's surface. Saturn is the gem of the heavens. For exquisite loveliness, it is unrivaled. The superb ring system which surrounds the yellow disk of the planet is alone in its glory, and its fascination never lessens. Basically, Saturn is not unlike Jupiter. It is a gas giant with no great mass, and it too has its huge cloud belts and spots. But Saturn is a quieter world than its giant brother. Although somewhat smaller, it still has a diameter of 75,000 miles, and it is much more remote, averaging 886 million miles from the sun. The rings of Saturn are the remains of material that was too close to Saturn to form a moon. The strong tidal pull of Saturn spread this material out to form the rings, which are composed of dust particles to boulders and covered with ice or snow. They are so thin, 1.7 miles, that when seen on edge, they virtually disappear. Easily the most important and exciting of our neighbor planets is Mars. Since first discovered, Mars has always been associated with tales of alien life, with great canals and immense cities. Since those days, thanks mainly to the Mariner series, we have learned a great deal. There are no canals, no great cities, no green Martians. But there are windswept, boundless deserts, gigantic geographical features like 40,000-foot mountains, and canyons that dwarf our own Grand Canyon. There are huge amounts of water ice and frozen carbon dioxide at the poles. Definite indications of a time in the past when water did flow freely and cut channels and canyons, much as erosion has occurred here on Earth. And there is now the serious possibility of some form of life on this exciting planet. Certainly it is a future goal for manned exploration. Venus is known as Earth's twin sister. Its cloud-shrouded surface has shed little of its secrets over the past many years, but finally some of these have been divulged by Mariner 10. Below its clouds, a torrid temperature of 890 degrees would allow pools of molten lead to exist. The surface pressure is 90 times that of Earth. A Russian space probe indicates that its soil is made up of rocks similar to earthly granite, and that only about 1/10 of the light is received by Venus at the surface as is received here on Earth. This because of the thick cloud cover. Not a very hospitable planet, and yet of great interest to us all. Little was known of Mercury just a few short years ago, but thanks to Mariner 10, we now have masses of information about this, the smallest and closest to the Sun of all planets. It orbits around it in an average of about 36 million miles. We know now that its surface is almost identical to the lunar surface, a cratered world scarred by billions of years of bombardment. It's a midget compared to Earth, not much larger than our moon, 3,000 miles in diameter. It is believed that the craters that we see date near the birth of the solar system, meaning that it has always been a quiet, stable planet. One of the most surprising things to come from the Pioneer 10 probe was the discovery that Mercury does have a magnetic field. Its surface temperature of the sunlight can be as high as 800 degrees plus, so it is not a place where any of us would like to live. The only star that we have an opportunity to study carefully and closely is our own sun. But what we learn applies to billions of other stars as well. It was born about 5 billion years ago. It is just an ordinary star, neither exceptionally bright or big, and it seems to be of middle age, which indicates 4 to 5 billion years of stable life left before its death process begins. It is 93 million miles from Earth and is 864,000 miles in diameter. In this photo, taken with a special filter, we see vast seas of churning hydrogen that cover its surface. The bright surface is mainly hydrogen and helium, and it has a surface temperature of 6,000 degrees centigrade. This is called the photosphere. Extending upwards from this layer is another called the reversing layer. The next layer, which extends to a height of 6,000 miles, is the chromosphere, and then lastly, the corona. Neither of the last two layers are visible except at the time of a total eclipse as seen here. It is believed now that the corona extends outward from the sun at least 7 million miles, and perhaps even as far as the orbit of our own planet. Of course, our very existence on this planet depends upon a stable sun. And this is one of the many reasons why scientists are so interested in sunspots, solar prominences, and solar flare. The great storms that swirl on the surface that affect our weather, communications, and create the aurora borealis. Here we see solar prominences, which are huge flames of hot gas that may extend to 1 million miles above the solar surface. Whenever we think about our sun, we cannot help but be amazed by the colossal energy that this gigantic atomic engine releases daily and has been releasing for thousands of millions of years. In studying our universe and our solar system, we cannot overlook the importance of comets and meteorites. At rare intervals, a frozen lump of primordial matter invades our part of the solar system. From Earth, we watch these celestial interlopers, the comets, as they gracefully fling their enormous tails millions of miles across interplanetary space. A large comet like Ikea-Seiki, as seen in 1965, is a rare and marvelous spectacle. A glimpse of an object as alien as anything ever seen in earthly skies. They come from some of the deepest regions of outer space. We cannot be certain, but it appears that their beginning may be within the great nebulae. We are fairly certain now that they're composed of ice or snow, sometimes miles in diameter, with a sprinkling of other cosmic matter that flakes off in increasing quantities as they enter our solar system and are heated by our sun. This slide and the next are rather remarkable as they show the moment of the breaking up of a meteorite within the Earth's atmosphere. Meteorites are small portions of comets or other space debris, mainly metals and various chemical compounds that are heated by the atmosphere as they enter it and rapidly burn up. Only the very largest ever reach the Earth's surface. The history of the evolution of man is tied in the strongest manner to what we see in the heavens. Man's first simple religious rites were induced by fear of this unknown. The ancients studied the awesome night sky, and this gave birth to man's first science, astronomy. Medieval writers constructed a cosmos in which angels moved about the celestial bodies. Not surprisingly, the challenge of the heavens has lured the greatest intellects from each generation of man. Their efforts to unlock the secrets of the heavens created our mathematics. Exploring the universe, they lifted the human spirit and compelled our souls to look upwards. Today we remain puzzled, for we're staggered by what we've learned and stunned by what we've seen. Despite this vast knowledge, we are still a long way from answering that final question, and perhaps we never will be able to answer it. What is the universe, and how was it created? Man now sees himself living on a small planet within a solar system and galaxy which is merely an imperceptible faint point of light in the everlasting vastness of unending space. Your bi-media program is now complete. Please rewind this tape and you will be ready to enjoy it again at your next showing.